What's up, guys? Welcome back to the channel. Today in this video we'll be doing this previous question paper that you see here. As you can see, this is a national certificate for mathematics and 4, and this paper was written on the 27th March 2025. It was an X paper that took 3 hours. Now on this particular video we'll be doing question 4. Just in case you haven't watched question 1, 2 and 3, I will leave a playlist on the description, and also that playlist will pop up on the top right of this video that you're watching here. But before we start, I'd just like to say thank you very much, guys, for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. If you haven't subscribed to the channel, subscribe to the channel, because we have done lots and lots of videos on previous question papers and also on mathematics problem. Again, guys, if you want to support this channel to grow, you can hit the super thanks button. That will highly appreciate it. But if you can't, a like and a comment will be really appreciated. So before we continue, I'd like to inform you that I will leave a timestamp for each and every question that you like to watch, just in case you don't want to watch the questions in a sequence order. All right, guys, let's look at question 4 and let's start solving it. All right, guys, here's our question 4. As you can see, question 4 has 4 questions. So we will be dealing with differentiation here on this question. We're going to start with question 4.1. Post it where there is space and let's solve it. All right, guys, here's our 4.1. As you can see, we are given the function here. So the function goes like this: f of x is equaling to x cubed minus 2x minus 4. Now we have the statement here. Let's read the statement and see what is it that they want from us here. They say, using differentiation, calculate the coordinates of the turning point and the point of inflation, and also distinguish between the maximum and the minimum turning point by using the second derivative. So let's analyze this question. First of all, they want us to use differentiation here, and they want us to find the coordinates, but the coordinates of turning point then, and also the point of inflation. So these are the coordinates that we should look for. And then they want us to distinguish between the maximum and the minimum turning point using the second derivative. Right, so we're going to start by calculating the coordinates of the turning point. So when we calculate the coordinates of the turning point, the function that is given to us here, we need to derive it once and equate it to 0. So when we derive this function that is given to us there, we're going to have dy over dx, which is equaling to 0, which is equaling to the derivative of the function there. So the first term, we're going to have 3x squared. The second term, we're going to have 2. And the last term is going to be 0 because it's a constant. Remember, when we're deriving the constant, the answer is 0. So when it's like this now, we have to solve for x. So let's solve for x. If we transpose this negative 2 to the left-hand side, remember the left-hand side is equaling to 0. It's going to give us positive 2, which is equaling to 3x squared. Let me rewrite it like this. 3x squared is equaling to 2. There we go. We divide by 3 throughout. So if we divide by 3 on both sides, we'll be left with x squared on the left-hand side. And then on the right-hand side, we're going to have 2 over 3. But we are not looking for x squared. We're looking for only x. So we need to square root on the left-hand side and on the right-hand side. But what you do on the left-hand side, I was also able to do on the right-hand side. So our x is going to be equaling to plus or minus the square root of 2 over 3, or plus or minus 0,816. There we go. So this here is going to be our x. Now that we managed to find our x, we need to find our y value. So our y values, we're going to have to substitute these x's on the original. When x is equaling to negative 0,816, what is our y? Remember, we have two x's here. One is positive and the other is negative. So when it's negative, what is our y? We take from the original equation there, we just substitute with negative 0,816 on our original equation there. So let's do it. So wherever there is x, we're going to put negative 0,816. But from the original, this is cubed. minus 2. Wherever there is x, we put negative 0,816 minus 4. You put this on your calculator, you'll get your answer, which is going to be negative 2,911 approximately. So even if you leave it like this, we can say this is our y. So you can say turning point 1, the coordinates are when x is negative 0,816, your y is going to be negative 2,911. There we go. So time for us to find the coordinate of turning point 2. So we do similar thing that we did there. When x is equaling to 0,816, remember this is 0,816. These are x values, but we have the negative and the positive. So this time around, when it's positive, what is our y? So let's create space a bit here so that you can able to solve it. Right. So as you can see, the original is here, underlining it there. Wherever there is x, we substitute with 0,816. So we know that 0,816 cubed minus 2 multiplied by 0,816 minus 4. So what is this y here? So our y is going to be negative 5,089. So when x is 0,816, our y is going to be negative 5,89. Right, more space need to be created. So we can say turning point 2, the coordinate on x is 0,816, or y is going to be negative 5,089. There we go. So we have these turning points here. So we managed to find the coordinates of these turning points there. There we go. Turning point 1 and turning point 2. So the first part of this question, it is complete. Now, let's go to the other part. So from here, I have to distinguish between which of these two is maximum and minimum. So guys, when you distinguish between the two, you need to do the second derivative. As you can see from the statement, they say distinguish between the maximum and the minimum turning point by using the second derivative. Now we need to do the second derivative in order for us to distinguish. So let's do the second derivative. As you can see, our first derivative is this one here. So when we derive this one for the second time, it's going to be d squared y over d x squared. Now when we derive this is going to give us 6x. That's it, because this 2 here is going to be 0. It's a constant, right? Now from here, we can check by substituting x values of the turning point. So we're going to substitute these values here, right, of the turning point. When our second derivative is less than 0, just know that it's a maximum. And when it's positive or above 0, just know it's a minimum turning point. So let's start. When we have d squared y over d x squared 6. So this time around, we're going to substitute when x is negative 0,816. So when you do this, this is going to give us negative 4,896. There we go. So when it's negative like this, it means that it's less than 0. So this means that this turning point here is the maximum. You can also write here maximum, guys. But next to this turning point, you can also write maximum next to it. Now let's check the other one. When now x is positive, let's check d squared y over dx squared. This time around, we substitute with x when it's positive. So it's going to be 0,816. So the answer is going to be similar, which is, so this here means it's minimum because it is positive or it is greater than 0. So next to it, again, you can write mini. So this is how you distinguish between the maximum and the minimum. Just make sure that you derive the second time and you also substitute the x values on your second derivative wherever there is x. Right, now what is left now is to calculate the point of inflation. Guys, the point of inflation is actually the point at which the graph increases or decreases. So I'm going to create space so that we can able to show you guys. Point of inflation, guys, right? You don't really have to write everything. Let's say you have a cubic graph like this one. The point of inflation is a point at which the graph starts to increase and decrease, or start to decrease and increase. Basically, it's a midway of a cubic graph. So an example could be this point that I'm showing you here. So guys, let me calculate the point of inflation. Again, with the point of inflation, you need to derive the second time. But this time around, you equate the second derivative to 0. So if you still remember from the previous derivative, we say d squared y over dx squared is equaling to 6x. But this is also equaling to 0. We've already done the second derivative earlier on. Now let's solve for x. We know that 6x is equaling to 0. So if we divide by 6 throughout, our x is going to be equaling to 0. This is the x-coordinate of the point of inflation. Now it's time for us to find the y-coordinate of the point of inflation. Whenever you are calculating for y value, always go to the original equation. So the original equation, it goes like this. We have y is equaling to x cubed minus 2x minus 4. So this time around, whenever there is x, we substitute by 0. Y is equaling to 0 cubed minus 2, 0 minus 4, meaning y is going to be equaling to negative 4. So our point of inflation is going to be 0, negative 4. There we go. Guys, this is how you do this question here. It contained lots and lots of marks, guys. I hope you managed to understand how to do this one. Just in case you didn't understand, you can go to the point where you got lost, try to rewatch it. And if that doesn't help, you can leave a comment in the comment section. But if you manage to understand this question from this video, do not forget to like and share the video to your friends. And also, if you haven't subscribed, subscribe to the channel. Guys, if you want to see this channel grow, you can support our channel by hitting the super thanks button. That will be highly, highly appreciated. But if you can't do that, a like, a comment, and a share will be highly appreciated as well. We are done with 4.1. I hope it was not as challenging as it seemed. So let's go and do 4.2. Now that you're done with 4.1, let's look at 4.2. Now here's our 4.2, guys. I'm gonna copy this question, paste it where there is space, and let's solve it. Okay, guys, here is 4.2. We are given this equation here. Y is equaling to root of cot x. They want us to differentiate using the chain rule here, or function of a function. So let's do it. Before we start, guys, we need to simplify this equation here. We can say y is equaling to cot x, and then instead of writing the square root, you're gonna write it to the power of half. So before you continue with the chain rule, you need to understand that you have two equations. You have a function within a function. So we have the whole function here, which is the square root of cot x. And also you have the inner function, which is actually cot x. So you have to equate the inner function with u. So if we can say u is equaling to cot x, we can say y is equaling to u, which is cot x, to the power of half, because cot x is u, but this cot x has the power of y. So from here, we have to derive both of these. So I'm going to start by deriving u. So when you say du over dx, remember we are deriving u with respect to x. So the derivative of cot x is actually negative cosec x. There we go. You can go to the formula sheet. The answer, it is there on the formula sheet. But then what about the derivative of u to the power of half? Again, here, do not forget, it's going to be dy over du. This time around, we are deriving y with respect to u. Right, so this is a standard derivative. It's very simple, guys. You have to multiply by the exponent, and then you subtract the exponent with 1 again. And then this is going to give you half multiplied by u to the power of negative half. So this is the final derivative here. Just in case you don't know much about the standard derivative, you can go to the description. I left a video explaining or introducing the standard derivative. Go and watch it so that you can understand further. So the next step is to multiply the derivatives of u and y. So in order for you to find dy over dx, you have to multiply the derivative of u with the derivative of y with respect to u. There we go. This du and du, they will divide each other. You're going to be left with dy over dx. Basically, that's what is happening. Dy over dx. Let's continue. We need to substitute du over dx. So du over dx, we know that is negative cosec x multiplied by dy over du. So our dy over du is this one, 1 over 2 u to the power of negative half. There we go. So if we simplify this further, we're going to have negative cosec x divided by 2 u to the power of half. Right, we are not done when it's like this. We need to first substitute this u to its original. Remember, u is cot, so we need to substitute that u. So we're going to write negative cosec x divided by 2. Instead of writing the power of half, we're going to put this inside the square root. And then instead of writing u, we're going to write cot x. There we go. So here's our answer here. I hope you can manage to see the final answer. It was really not that difficult to do it. What you needed to know is how to do the chain rule. Just in case you didn't understand or you don't know much about the chain rule, I left a video on the description explaining how does the chain rule work and how to apply it. So you can go to that description, click on the link, and also the very same video will pop up on the top right of this one that you're watching here. And again, guys, if you didn't understand, you can go to the point where you got lost, rewatch the video. And if that doesn't help, you can also leave a comment in the comment section. But if this part of the video helped you to understand how to differentiate using the chain rule, you can like the video, share the video. If you haven't subscribed, subscribe to the channel. If you want to support us, guys, if you want to see the channel grow, you can also hit the super thanks button. That will be highly appreciated. But if you can't, likes and share are really appreciated as well. Right, guys, we are done with 4.2. We're going to do 4.3. Let's do 4.3 here, guys. So I'm going to copy this question, paste it where there is space, and we solve it. All right, guys, let's look at 4.3. Now, 4.3, they want us to differentiate with respect to y, meaning now this is going to be equaling to x. Just in case you're not used to this, pay attention to this. It was a little bit of trick there. So you must also make sure that you are aware of this while you're solving. All right, so before you differentiate, there are a few things that you need to do, guys, here. You need to check each and every term, whether it is simplified or not. Now, when I look at the first term, I can see that it needs to be simplified. The second term also needs to be simplified, and the rest, they are fine. So it means that we need to simplify before we differentiate. So let's do it. X is equaling to the first term. We need to take this y from the denominator to the numerator. So we know that this y is y to the power of 1 over 3. So if we take it to the numerator, it's going to be y to the power of negative 1 over 3. There we go. Now we go to the next term. The next term we have 1 over cosec 2y. So this here is an inverse of sine. So you can rewrite it as sine 2y. There we go. Just in case you don't know much about inverses, I will leave a video on the description explaining these inverses. Then go to that video, click on that link, and also the very same video will pop up on the top right of this one here. Right, so let's continue. Now let's look at the third term. We have natural log y. So this one is already simplified, nothing we can do there. Let's look at the fourth term. We have e to the power of 2y over 4. There we go. And let's look at this term here. We have 5 to the power of 3 pi y over 2. All right, let's look at the second last term here. We have minus them. Anything to the power of 0, we know that is equaling to 1. Doesn't matter, guys, what it is, as long as it has the power of 0 is equaling to 1. We continue on the last term, we change nothing. We have 6p, then y. Right, so when it's like this now, we can able to differentiate. But before you differentiate, make sure you recognize each and every term, what type of derivative that you need to apply here. All right, so let's do it. So this time we're going to say dx over dy. Do not forget, guys, we are deriving x with respect to y. So the standard derivative on the first term is going to be negative 1 over 3. There we go. Multiply by y, then we have negative 1 over 3 minus 1. So this is the first term. Now let's look at the second term. We have minus there on the second term. We have 2y, the coefficient of y. So when you do this one, we know that this 2 is going to be multiplying the whole thing. And then now, what is the derivative of sine? It's going to be cos, positive cos, by the way. And then 2y. Just in case you don't know much about the trigonometric derivatives, I'll leave a video on the description where I explain how this came about. So you can go to that video, click on the link, and also the video will pop up on the top right of this one here. All right, let's go to the third term, which is ln y. When we derive this term, it's going to be 1 over y. Again, for this one, guys, you can go to the description. I left the video where I explain how to derive this one as well. So go to that video. Right, let's go to the fourth one. This is an exponential because y is an exponent. So with an exponential, we know that this is going to be minus multiplied by minus 2. There we go. E to the power of negative 2y. This 2 here is a coefficient of y. Divide by 4. Natural log e. So this is an exponential. Again, there is a video on exponential derivative. I will also going to leave that video on the description, and also the video will pop up on the top right of this one here. All right, let's look at the fifth term. When we differentiate the fifth term, which is also an exponential equation or derivative, we're going to apply the very same thing that we did on the previous term. We want to multiply by the coefficient of y, which is in this case 3 pi. And then we multiply by the base, which is 5 to the power of 3 pi y. Divide by 2. Let us not forget that natural log, then 5. Right, or the base. Now, let's look at the second last term, which is negative 1. This is a constant here, even if you put negative 0. And then the last term, which we have plus 6py, this is going to give us plus 6p. I hope you can able to see that. Guys, this is how you differentiate each and every term that we have here. Well, when it's like this, guys, it means it's not simplified. How about we simplify the terms that needs to be simplified? So we continue dx over dy. Let's start with the first term. As you can see, the first term we have negative 1 multiplied by y. We can say y to the power of negative. Let's not forget we have negative 1 over 3 minus 1. So it's going to give us the power of negative 4 over 3. There we go. Divide by 3 there. Right. Minus 2 cos 2y. So the second term doesn't need to be simplified. And the third term is still fine. We don't need to simplify it. But the fourth term, we have negative multiplied by negative. First of all, this is going to be positive. And we're going to have this 2 divided by 4. So 2 divided by 4, it's actually half or 1 over 2. So meaning on the numerator, that one we multiply with e to the power of negative 2y. There we go. Divide by 2. Now, natural log e is the same as 1. So even if you don't write it, it's fine. Plus. Right. Let's look at the third last term. So here you don't do nothing. It is fine like this. 3 pi multiplied by the base divided by 2. Natural log 5. Guys, on this one, people tend to multiply this 3 pi with the base. Do not multiply these two, guys. This 3 pi is just a number that has the power of real number. whereby the base, which is 5 to the power of 3 pi y, this is basically a base that has the exponent of unknown. We don't know what y is, so we cannot multiply this 5 with the 3 pi there. And then we say minus 0. Please include this 0. Sometimes it's a mark. And then we say plus 6. Right, so this is your answer. You can go further though and simplify the first term. So let me just create the space there so that you can see the final answer. Let's continue. Dx over dy is going to give you negative 1 over. It's time for us to change here. If we change this exponent to positive, this is going to be y to the power of 4 over 3 minus 2 cos 2y plus 1 over y plus e to the power of negative 2y over 2 plus 3 pi multiplied by 5, 3 pi y divided by 2 natural log 5 minus 0 plus 6p. Guys, this is your final answer. I wouldn't say don't go further than this, guys. This is enough. All these derivatives that you see here, we've done them before on this channel. I'm also going to leave a playlist with the polynomials where it contains different type of derivatives. So go and click on that playlist and see how I solve a lot of polynomials similar to this one. If this video helped you to understand, do not forget to like, share, and also subscribe to the channel if you haven't subscribed to the channel. If you want to see this channel to grow, or if you want to support us, guys, you can also hit the super thanks button. That will be highly appreciated. But if you can't, the like, comment, and the sharing will be highly appreciated as well. Just in case you didn't understand, you can go to the point where you didn't understand and rewatch it. If that doesn't help, you can leave a comment in the comment section. Guys, we are done with 4.3. It's time for us to do 4.4. Okay, guys, let's look at 4.4. I will copy this question, paste it where there is space, and let's solve it. All right, guys, let's look at 4.4. By using the quotient rule, differentiate y is equal to cot x. Right, so this time around, they want us to use this rule here, which is the quotient rule. Just in case you didn't know, we know that you can represent cot as cos x over sine x. So this is a way that you can use the quotient rule. Remember the quotient rule, it needs the numerator and the denominator. Some people, they prefer to do it this way, 1 over tan x. Still, both of these will give us the correct answer. So I'm going to start with the one here on the left. We need to name our numerator f of x and then our denominator g of x. So when it's like this, it's easy for us to use the quotient rule. Now, f of x prime is a derivative of the numerator, which is cos. What is the derivative of cos? It's going to give us negative sine x. And then g of x prime is a derivative of the denominator. In this case, is sine. So what is the derivative of sine? Is going to be positive cos x. Right, so from here we can start using the formula. All right, let's write down the equation of the quotient rule. So when you're looking for dy over dx, the equation is very simple. On the numerator, you're going to have the derivative of f of x, which is f of x prime, multiplied by g of x. There we go. Minus. Now, the second term on the numerator, this time around f of x multiplied by g of x prime, the derivative of g of x. All this is going to be divided by g of x squared. There we go. So basically, this is the formula that you're going to use when you derive using the quotient rule. Right, so we're going to continue here. Let me just create some sort of space there. And let me erase this one here. So if we continue from here, we can say dy over dx. F of x prime is going to be negative sine x multiplied by g of x. G of x is just sine x. There we go. Let us not forget the equation says minus here. So we say minus. F of x is going to be cos x multiplied by g of x prime, which is going to be cos. So it's going to be cos x. All this divided by g of x squared. So our g of x, which is sine, going to be squared there. So we continue. dy over dx here. We know that on the first term on the numerator, we have negative sine multiplied by negative sine. This is going to give us negative sine squared x minus negative cos multiplied by negative cos. This is going to give us minus cos squared x divided by sine squared x. There we go. So on the numerator there, we can take out the common factor, which is negative 1. There we go. We'll be left with sine squared x plus cos squared x divided by sine squared x. There we go. Now, when you look on the numerator, if you continue here, when you look at the numerator, we know that sine squared x plus cos squared x, that is going to give us 1 multiplied by 1. So this is going to give us negative 1. Just in case you didn't know, guys, I'm going to write it here. Sine squared x plus cos squared x. This is equaling to 1. That is a square identity, guys. Right, let's continue. If this is negative 1 multiplied by 1, so we're going to have negative 1 on the numerator. Divide by sine squared x. Right. We create a bit of space there. So we can say dy over dx. We know that negative 1 over sine squared, we can use the inverses here. We know that's going to be negative cosec squared x. There we go. This is our final answer when we take this route here. Really, it was really not that difficult. So you needed to know your inverses here. So how about when you use this one of 1 over tan? So on this one, you can say f of x is 1 and then g of x is actually tan x. So f of x prime on this one is going to be 0 and then g of x prime is going to be sec squared x. There we go. So let's see if you can able to use this formula here for this one. The formula goes like this: dy over dx, remember, is a derivative of f of x, which is going to be 0, multiplied by g of x, our g of x, which is tan x, minus. Now, the second term on the numerator, we have f of x, which is 1, multiply by the derivative of g of x, which is sec squared x. All this is divided by g of x squared, tan x squared. There we go. Now, if we continue here, we will have 0 multiplied by tan on the numerator, which is 0. So negative 1 multiplied by sec squared is going to be negative sec squared. There we go. Divide by. So we're going to divide by tan squared x. All right, guys, let's create space so that we can continue on this one. When we continue here, guys, we can write this negative sec as negative 1 over cos squared x. There we go. Divide by. We can write tan squared x as sine squared x divided by cos squared x. Remember, this negative 1 over cos squared is actually the same as negative sec squared. Now, we can also write tan squared x as sine squared over cos squared. These are quotient identities. Right, so let's continue. We're going to say negative 1 over cos squared x. We change this division into multiplication. The denominator becomes the numerator, which is going to be cos squared x. And then the numerator becomes the denominator, which was sine squared x there. So we know that this cos squared x and that cos squared x will divide each other. You'll be left with negative 1 on the numerator, and then the denominator you're left with sine squared x. So this here, we know that 1 over sine is cosec. So we can say minus, then 1 over sine is going to be cosec. Let's not forget the square there. So as you can see, this is the same as that one there, guys. These two answers are the same. I hope you guys managed to understand this because it was really not that difficult, even though I show you two ways of solving this. So I hope you managed to understand it. If it so happened that you didn't understand it, you can go to the point where you got lost, rewatch at that point, and if still you don't understand, you can leave a comment in the comment section. I'll try to answer you to my level best. But if this part of the video helped you to understand, do not forget to like, share, and also comment. If you haven't subscribed to the channel, subscribe to the channel. Guys, if you want to support this channel, you can also hit the super thanks button. That will be highly, highly appreciated. But if you can't do that, you can always like, share, and subscribe if you haven't subscribed. We are done with 4.4. I will leave a playlist that contains all the questions of this question paper at the end of this video. Go and click on that playlist to watch all the questions there. Alright guys, we are done with question 4. Next time we'll do question 5. Thank you very much guys for watching. Till next time, cheers.